Alright, so good day everyone. Jadi hari ini kita akan explore the fundamental of a 3D modeling technique. Yeah, we are going to explore fundamental of a 3D modeling technique yang sangat penting dalam product design. Yeah. Okay, so awak semua sebagai future engineers, designers, or sustainability advocates, you need to understand how digital modeling tools will help to support the development of innovative and environmentally conscious product. Yeah. So sesi kita pada rakaman kita pada hari ini adalah 3D modeling technique dalam product design from primitive to parametric, and we will walk through the key modeling approach such as primitive modeling, boundary representation, constructive solid geometry CSG, dan juga parametric modeling. Yeah. So semua teknik, all these technique form the basic of many computer-aided design tools that we use in industry today, such as AutoCAD, SolidWorks, Inventor, CATIA, and so on. All these tools, they are not only powerful, but also highly relevant for sustainable design strategy. So by the end of this lecture, you should be able to distinguish between all these modeling methods, understand where and why each is used, and appreciate how these tools will contribute in optimizing materials, reducing waste, and improving product performance in designing a project. So from the figure here, we can see that we can see a geometric 3D primitive like cone, sphere, cylinder, and cube. Semua ni adalah foundational shape used to construct a more complex 3D model. Yeah. So this primitive kita panggil semua bentuk-bentuk ni sebagai primitive. Ya. Kita boleh manipulate, ataupun kita boleh combine to form detailed design in computer-aided design case of way. And this approach is common in early stage modeling due to its simplicity and efficiency. So dalam slide ni kita boleh nampak beberapa lagi 3D primitive shape used in computer-aided design ataupun CAD and modeling, and these shape, all these shape form the basic building block for more complex model dalam engineering design. Yeah. So the first shape we can see here is a cone. A cone is a tapered shape with a circular base. Selalunya kita guna dalam mechanical part. Yeah. And then kita ada cylinder. Cylinder is common dalam pipe dan juga shaft modeling. And then we have a wedge. Wedge is useful in structural and mechanical design for angles, faces. And then we have a pyramid. Pyramid is a base with triangular faces used in architectural modeling. Lepas tu kita ada block ataupun kita panggil sebagai cuboid. This is a very common in modeling solid component. Then kita ada torus. Torus is a donut shape object often used in modeling rings ataupun a seal. And then kita ada sphere and a hemisphere. Yeah. Often used in modeling ball, dome surface, and so on. So all these primitive serve as the starting point for solid modeling, especially dalam parametric dan constructive solid geometry CSG approach. Okay, so dalam figure ni, so this image demonstrate the primitive modeling. That is a fundamental solid modeling technique where the basic geometric shape kita combinekan untuk membentuk a 3D model. Yeah. So primitive modeling uses a standard geometric shape such as a block. We have a block here, A dan juga B. that are rectangular prism. And then we have a cylinder, that is the orange cylinder here that we attach to block A. And kita ada wedge kat sini, a green slope shape position on the top of a block B, right? So dekat A ni, in A here, it shows the individual primitive before Boolean operation, and B is the result after we combine all the primitive shape using a Boolean union operation. All right, so the key concept here is that this method is widely used in early stages of computer-aided design modeling because it is fast and intuitive, makes it suitable for conceptual or mechanical part. Yeah. So this is often used in constructive solid geometry, CSG, as part of the Boolean operation, including that consists of a union, subtract, and intersection. So now we move on to the concept of boundary representation, or BREP. This is a key method for representing a 3D solid in CAD and simulation software. So boundary representation define a solid by boundary, specifically faces or surfaces, edge, ataupun line, dan juga vertices, point. Yeah. So it provides geometric and topological data, which is essential untuk precise modeling. So BREP ni commonly used in finite element analysis, FEA, because it offers accurate surface and boundary detail, which is critical for meshing dan juga stress analysis. So dalam figure ni kita boleh tengok bagaimana solid is broken kepada bounding surfaces and dijana semula reconstructed into a wireframe like model that retains a shape and also the geometry through its boundary data. So dalam ni kita boleh, saya akan terangkan the boundary representation, BREP, by visually label the three main component. So kita ada vertices. Yeah, vertices is a corner point where the edges meet. And then kita ada edges here. Edges ni is a straight line that connecting vertices and forming the outline of faces. And then kita ada faces, permukaan ni, the flat surfaces enclosed by edges, defining the exterior of the solid. Jadi daripada gambar ni, this visual can help us to identify how solid is defined dalam BREP, boundary representation. It is not by volume, tetapi by its outer boundary. Yeah. So this is especially useful in application like finite element, where the accurate surface definition sangatlah penting. Right. Okay, so now we move on to the next slide. We can see here, this is we discuss some on a finite element. Yeah. So finite element analysis, or FEA, it is a simulation tool that use the finite element method to assess how real world forces, for example, contohnya macam stress, heat, vibration, macam mana, how all these real world phases will affect the product design. Yeah. So BREP geometry is often used in finite element because its precise definition of faces, edge, and vertices, it makes it ideal for what we call as meshing. Yeah, meshing, M-E-S-H-I-N-G, meshing. Di mana kita akan break down a model into smaller, manageable parts of finite element. And from the figure here on the right, it shows a color-coded stress distribution result, di mana yang merah ni adalah indicating a high stress. and the blue one indicates a low stress. So tujuan dia, finite element dia boleh membantu engineer to detect weak point before physical prototype are made, and as a result it can help us to save time and also cost. Yeah. All right. So from here, I will introduce you to constructive solid geometry ataupun CSG. This is a technique for building a complex 3D model by combining a simple shape using a Boolean operation. So a CSG or constructive solid geometry relies on a 3D primitive such as a cube, sphere, and so on melalui union. Union is a merge of a two solid into one, and then we have a subtraction. Subtraction adalah di mana kita remove a part of one solid using another, and also we have an intersection. Yeah, intersection is where we keeps only the overlapping portion. So software yang menggunakan constructive solid geometry contohnya adalah AutoCAD dan juga software yang kita gunakan dalam Makmal lah. Contoh macam SolidWorks. Yeah. Jadi daripada figure here, from the image here we can see we have a blue sphere and orange cube. So we can see the blue sphere and orange cube interact in three different ways to produce a new geometry. Yeah, we have an intersection, we have a subtraction, and also we have an addition here. So this approach is very useful dalam parametric modeling. Yeah, parametric modeling, terutamanya dalam mechanical design. Here we can see a Boolean tree. Yeah, a Boolean tree is a hierarchy structure that records the sequence of a Boolean operation used to build a model. Yeah, so kita boleh nampak hierarchy structure yang menunjukkan the sequence of a Boolean operation untuk membina model. So it start with A, dan kita subtractkan dia, yeah, and then the union the result with C, yeah, this one, and the tree shows the flow from individual primitive ABC through operation to the final shape. Jadi kenapa benda ni penting untuk kita faham? Sebab Boolean trees allow for easy editing and parametric update since each operation and component is retained, and it is efficient for feature-based modeling dalam computer-aided design software. Yeah. All right, so we move on to the next slide, and this slide here shows a step-by-step example of a solid modeling using constructive solid geometry. The first one, kita ada union. We have a union here. We have a cylinder, and then kita ada rectangular block. We combine A and B, resulting in a C, a joint base shape. Yeah. And then we have a step 2, that is a subtraction, where the C that combined model from step 1. And then we have a D, a smaller cylinder here. We subtract a D from C, and this will result in E. Yeah, kita ada E, which has a hole ataupun notch removed. And then finally, kita ada step 3, that is the final subtraction. We have a E from the previous result. And then we have a F here, another shape. We have F, another shape here. And we subtract F from E, and it will give us the final complex solid. So tujuan dia di sini adalah untuk menunjukkan, yeah, to illustrate you how a complex model built using a simple primitive and Boolean operation, ya, untuk menunjukkan kebolehan CSG workflow dalam CAD system. So di sini I want to introduce you to parametric modeling. I think you already encountered this term before. So this is a powerful approach in 3D computer-aided design where the model geometry is driven by parameter. So the key concept here is a dimension control geometry where the changing a value, for example, the length or radius, it will automatically update the model's shape. So it is a feature-based, meaning that the models are built from modular features like a hole, groove, fillet, dan juga chamfer. Yeah. So this is very ideal, sangat ideal for design iteration, since we can edit, update. One edit, when we do one edit, it can automatically update the entire model intelligently. Yeah. Contohnya macam dalam software SolidWorks yang kita gunakan, ya? Dan juga dalam beberapa software yang lain lah. So why it is important? Because parametric modeling help to increase efficiency, ensure design intent, and makes updating models much faster. So this is very ideal for engineering dan juga product development. Alright, so dalam slide ni saya akan terangkan. I will explain to you the extrusion technique. This is a very fundamental feature dalam parametric modeling. I think all of you already familiar with extrusion sebab kita dah buat ataupun hands-on menggunakan software SolidWorks dalam makmal komputer, ya. Alright, so what is extrusion? Kita boleh tengok dalam figure ni, we have a 2D profile. Contohnya macam rectangle. So sini kita ada rectangle. We have a rectangle here or circle. It can be rectangle or circle. It is extended in a straight line to create a 3D object. Yeah. So the operation performed in a linear sweep. In a linear sweep, perpendicular to the profile plane. And we can see that the cross section remains constant from the beginning to the end of the extrusion. Okay, contohnya dalam figure ni on the right here, we can see it is a straight vertical extrusion, and we have an oblique here in a slanted direction. But this one we have invalid or no extrusion because the direction is not perpendicular to the profile plane. Right? So extrusion is one of the simplest and the most common ways for us to create a solid geometry dalam CAD software. It is especially useful when we want to construct parts like beams, posts, and many more. And then here we have a sweeping. Sweeping is a 2D profile. We can see here in sweeping, we have a 2D profile. It will move along a predefined path, and it is not necessarily straight, as you can see in the figure here. And unlike extrusion, the path can curve or it can bend, but the cross section will stay the same throughout the material. And this is common untuk modeling pipe, wires, rail, dan juga complex shape that follow a specific route. Yeah. So we can see here the shape, it follows the path exactly, and making it ideal for modeling flexible ataupun elongated part. And here we have a revolving. So kita ada revolving. The profile is rotated. Dalam revolving, we can see that the profile is rotated around a defined axis, typically between 0 to 360 degree. And this will generate an object like radial symmetry, such as a bottle, a ball, a wheel, and many more. Yeah. So the cross section, it will remain constant as it sweeps. Yeah, as it sweeps in circular motion. So revolve is very useful when we want to create parts that are naturally round or symmetrical around a center line. So here we can see the overview of the type of a 3D modeling that we have learned so far. Yeah. So we have here we can see 3D modeling techniques that are commonly used in computer-aided design and computer graphic. The first one, we have a 3D modeling. The overall category for 3D modeling is the overall category for creating digital representation for a 3D object on the top here. And then here we have a wireframe that use only edge and vertices to represent object. It looks like a skeleton. Dia macam skeleton ni, macam tulang of the model. And it doesn't have surfaces dan juga volume. And then we have a surface modeling. We have a surface modeling that builds upon wireframe by adding surfaces, creating a skin-like appearance. This is sangat berguna untuk aesthetic and also aerodynamic design, but lacks the volume information. And the next one, we have a solid modeling. This is the most complete form, defining both surface and volume. And this includes several methods, as we can see here. Yeah, the first one, we have a primitive modeling that uses basic shape, such as cube, cylinder, sphere, and so on. And we have a boundary representation that define object by their surface boundary. And also we have constructive solid geometry that combine primitive shape using a Boolean operation. Yeah, as if you still remember, we have three types of Boolean operation that we have learned. We have a union, we have a difference, and we have an intersection. And also we have a parametric modeling that in here it allows changes through parameters and constraint. And this one is ideal for design update.